My name is Betsy Ogburn. I'm Associate Professor of Biostatistics. I've been here since 2013, I think. I ended up here because Michael Rosenblum visited Harvard, where I was a postdoc, and I got to know him a little bit, and he invited me, when I was still a postdoc, to come visit Hopkins for just a couple days. And as soon as I landed here, I knew I wanted to get a job here. It was just like the halls were full of laughter and people were talking and eating lunch together, and the seminar was really vibrant, and I just fell in love with the department and set my sights on it and felt very, very fortunate to get a job here. I fell into biostatistics a little bit accidentally. I studied philosophy and math as an undergrad, and I really loved both of those fields, but I wanted to do something useful and grounded, and I struggled for a while to figure out what that would be, and then kind of happened on causal inference as a subfield of statistics. I'm very grateful that I've landed in this field. I work on methods for causal inference from non-experimental data with complex statistical dependence. So causal inference is about learning cause and effect relationships. So does this intervention causally affect this health or societal outcome? In causal inference, you want to understand the underlying mechanism that gives rise to a link between an exposure and an outcome, or a treatment and an outcome. I was initially interested in causal inference because it's the perfect marriage between math and philosophy, and it's very kind of heady and deep, but also extremely useful. So it really marries all of the things that I wanted in a discipline. Causal inference is exploding in interest right now, which is both exciting and disconcerting. When I started working in causal inference, we were kind of like a niche, underappreciated field, and now everybody wants to do causal inference. People are starting to appreciate the importance of causal inference in machine learning and AI. So the interest isn't just within biostatistics or statistics. It's really like it's much broader, and I think I guess I think something exciting that I would predict over the next 5 years is the infusion of causal inference concepts and methods and ideas into AI. I hope that my research on causal inference will kind of protect against flawed analyses or like unsubstantiated claims. I think that there's a real inclination to just like a kind of human cognitive tendency to interpret associations causally. And if I could have any impact, it would be to kind of spread a kind of cautionary stance towards over-indexing on causality when analyses are messy or don't license causal conclusions. I just love the environment here. I love how friendly and collaborative everybody is. The department really cares about its members, both the individuals and just kind of like the way the department is set up. It's really supportive of faculty and I think also staff and students. Certainly that's the intention. And yeah, I hear stories about other academic environments, and I just feel so grateful to be in such a friendly, supportive place. It's an extremely flexible area to work in. It's basically as broad as statistics, plus various areas of like computational biology and biotech and epidemiology, and I think like the types of things that you can do in biostatistics are just so wide and varied. Anybody who has an inclination towards biostatistics would be able to find a happy home somewhere in the wide breadth of things you can do.